future of everything. We've got 3i Atlas updates and maybe even our best shot yet to clearly see the third interstellar object ever detected passing through our solar system.
When NASA announced that the interstellar visitor 3i Atlas would soon make its way past Mars, the scientific community and the public alike turned their attention skyward with a renewed sense of awe.
And according to astronomers, 3i Atlas has all kinds of surprises. We've only seen a handful of blurry shots. That there's the unusual chemical signatures. It's producing way more nickel than iron, and scientists don't really know why.
Objects like 3i Atlas, interstellar bodies that enter our solar system from beyond, are exceedingly rare, and each passage provides scientists with a fleeting yet extraordinary opportunity to learn about the galaxy beyond our sun's domain. The fact that this body is heading toward a rendezvous with Mars adds a layer of fascination, as it will pass close enough to allow Mars-based instruments, Earth-bound telescopes, and possibly orbiting spacecraft to observe it in ways that were never possible with its predecessors. The event promises not only a chance to expand our knowledge of interstellar objects, but also to probe the mysteries of planetary science, cosmic chemistry, and the story of how matter travels between the stars. Before we start, smash the like and subscribe buttons for more updates. 3. I-Atlas carries with it a designation that marks its place in history. The 3i signifies that it is the third confirmed interstellar object to pass through our solar system, following the groundbreaking discoveries of 1i/Oumuamua in 2017 and 2i/Borisov in 2019. Unlike asteroids and comets that originated within our sun's gravitational influence, interstellar objects formed elsewhere, around distant stars, in alien planetary systems, or perhaps even in turbulent stellar nurseries before being ejected into the interstellar medium. By sheer chance, 3i Atlas is cutting across our region of space, giving astronomers a laboratory on the move, a piece of the galaxy delivered across light years and now intersecting with the orbit of Mars. The trajectory of 3i Atlas is what makes this encounter with Mars so thrilling. Most interstellar objects sweep through the solar system at great speed, which makes observing them a race against time. With Mars positioned close to its path, spacecraft orbiting the red planet could have front-row seats to record its characteristics. Unlike Earth, Mars does not have a thick atmosphere that obscures certain wavelengths of light, meaning instruments in orbit or on the surface could potentially collect clearer spectroscopic data. Such data can reveal the chemical composition of the object's surface and its coma, if it has one, allowing scientists to compare it with the material we see in solar system comets and asteroids. Every spectrum, every data point, becomes a clue about where in the galaxy this object originated and what conditions shaped it. For planetary scientists, the Mars encounter opens unique opportunities. Imagine the rovers currently operating on the Martian surface, like Perseverance, potentially turning their cameras skyward to capture a glimpse of this traveler. Although their instruments are primarily designed for ground-based exploration, even a faint image of 3i Atlas from the Martian perspective would be remarkable. Meanwhile, orbiters such as MAVEN and Mars Reconnaissance Orbiter could provide high-resolution observations that supplement Earth's own telescopic efforts. This collaboration across worlds, Earth and Mars, both watching the same interstellar visitor, underscores the interconnectedness of planetary science in an age of interplanetary observation. The presence of 3i Atlas near Mars also raises important questions about the role of interstellar objects in planetary evolution. If Mars, like Earth, has experienced close encounters with such bodies in the past, might some of its own history, its water, its organics, or even the ingredients for potential life, be linked to materials seeded by interstellar messengers? Studying this object allows scientists to test hypotheses about panspermia, the idea that life or its building blocks can be distributed across star systems via comets, asteroids, or dust. The detection of organic molecules on 3i/Atlas, should they exist, would suggest that the conditions for life's chemistry might be widespread in the galaxy, carried along by countless icy fragments moving between stars. There is also a deeper implication for astronomy as a whole. Interstellar objects are like messages from distant regions we cannot yet reach with spacecraft. Every measurement of 3i Atlas, its speed, its rotation, its spectrum, becomes part of a growing library of data about matter forged under different stellar conditions. Whereas 2I/Borisov appeared as a relatively normal comet by solar system standards, 1I/Oumuamua defied easy classification, lacking a visible coma but showing signs of outgassing in puzzling ways. The anticipation surrounding 3I Atlas rests on whether it will resemble one of these predecessors, diverge from both, or introduce new mysteries. Its passage past Mars gives astronomers a rare second vantage point, adding more depth to the picture. Beyond its scientific value, the approach of 3I Atlas captures the imagination in ways that few events can. The thought of material from another star system brushing past Mars, a planet already central to humanity's dreams of exploration, has a poetic symmetry. Mars has long stood as the symbol of our first great step outward, the world that could one day host human colonies. Now an interstellar visitor will briefly share its skies. To stand on the Martian surface were humans already there, and look up to see a faint traveler from across the galaxy pass overhead would be a reminder of how small yet connected we are in the cosmic web. The logistics of observing 3I Atlas are complex, yet they drive innovation. Ground-based observatories on Earth will coordinate to track it during its Mars passage, while space-based telescopes may attempt to capture its finer details. Mars orbiters, if they are tasked with observing it, will need careful planning due to the rapid movement and faint light of the object. These challenges push engineers and astronomers to refine their methods, building skills and techniques that will prove essential for future interstellar studies. With each interstellar discovery, the astronomical community is becoming more adept at recognizing, tracking, and analyzing these rare visitors. The Mars passage of 3Y Atlas is therefore both a scientific milestone and a rehearsal for the more frequent detections expected in the coming decades. The mere fact that 3 interstellar objects have already been detected in just a handful of years suggests that the galaxy may be filled with such wanderers. Our ability to spot them has grown with the advent of more advanced surveys and automated telescopes capable of scanning wide swaths of the sky. The Mars encounter highlights the necessity of readiness. With faster detection, astronomers could one day dispatch spacecraft to rendezvous with such objects. In fact, space agencies are already studying mission concepts that could intercept future interstellar visitors, capturing images and even samples. The Mars passage of 3I Atlas makes these ambitions feel less like dreams and more like the natural next step. This event also invites reflection on humanity's place in the cosmos. 3I Atlas is not just a piece of rock and ice, it is a fragment of a distant system, perhaps ejected billions of years ago, now intersecting with the story of Mars and Earth. That cosmic timeline dwarfs our own histories, yet by studying it, we connect ourselves to the broader narrative of the galaxy. Every observation made during its passage past Mars ties human knowledge to events unfolding across interstellar distances. It is as though the galaxy itself is reaching out, placing a token of its vastness within our grasp. The anticipation surrounding 3I Atlas's journey near Mars is driven not by spectacle alone, but by the sheer breadth of questions it raises. Will its surface chemistry resemble that of comets in the solar system, or will it reveal exotic compounds forged in environments unlike any we know? Could its orbit hint at gravitational interactions with unseen bodies in its home system, offering indirect clues about planets orbiting distant stars? Might its dust and gas, if released, carry isotopic signatures distinct from anything we have encountered locally? These are not idle curiosities, but pressing scientific inquiries that could reshape our understanding of the galaxy's diversity. As it approaches, astronomers are preparing to use every available instrument to wring knowledge from the opportunity. Mars's orbiting spacecraft, Earth's largest telescopes, and perhaps even the James Webb Space Telescope could all contribute to a composite portrait of 3I Atlas. Each observation adds a pixel to the picture, each data set another thread to the tapestry of galactic knowledge, and as the object sweeps past Mars, it carries with it the reminder that the boundaries between planetary science, astronomy, and astrobiology are porous. A single interstellar visitor can touch them all. The encounter will be fleeting. Interstellar objects do not linger. They streak through the solar system at immense speeds, never to return. Yet within that brief window, Mars and Earth will share the skies with 3Y Atlas, both worlds turning their instruments outward in a rare act of joint cosmic observation. The implications for science are profound, but so too is the symbolism. Two planets aligned in their gaze upon a galactic traveler, one still awaiting human footsteps, the other already teeming with observers eager to understand their place in the universe. The excitement around this passage lies not in any immediate consequence, but in the way it deepens our perspective. Mars, so often imagined as the next great frontier, will temporarily host a visitor from even farther away, reminding us that the solar system is not isolated. The Red Planet, already a destination of dreams, becomes part of a larger drama playing out across light years. For those who study the cosmos, 3I Atlas is not just a distant speck of light. It is a bridge between worlds, a reminder of the galaxy's immensity, and a herald of discoveries yet to come. The announcement that 3I Atlas is soon to sweep past Mars continues to unfold as one of the most captivating astronomical events of our era. What sets it apart is not only the rarity of such interstellar visitors, but the richness of scientific, philosophical, and cultural implications that this passage carries. For centuries, humanity has gazed at Mars with longing, crafting myths about its role as the god of war, speculating about canals and civilizations, and now sending fleets of robots to crawl its surface. But to witness another world from far beyond the solar system pass close to the Red Planet feels like the universe itself has conspired to layer wonder upon wonder. This interstellar encounter is not just an astronomical waypoint. It is a moment that weaves together threads of exploration, cosmic heritage, and human imagination into a single, fleeting alignment. The story of 3I Atlas is, in many ways, the story of movement and displacement on a scale that dwarfs all human journeys. Astronomers believe that interstellar objects like this one are fragments, once part of a planetary system orbiting a distant star. Through gravitational nudges, collisions, or stellar upheavals, they are ejected into interstellar space, embarking on voyages that can last billions of years. During this time, they are shaped by forces unimaginable. Cosmic radiation, encounters with interstellar dust, and the slow erosion of their outer layers by energetic particles. By the time they enter our solar system, they carry with them the fingerprints of environments utterly alien to us. That Mars, of all planets, is the one they now approach adds a poetic quality to their odyssey. Mars itself is a world of loss, a planet that once had rivers and lakes, perhaps even oceans, only to lose much of its atmosphere and water to the void. The meeting of a planet scarred by its own history with a traveler scarred by eons in interstellar space seems less like coincidence and more like a cosmic dialogue between survivors. One of the most profound implications of this passage is the way it reframes our understanding of planetary science. For decades, scientists have tried to determine whether Mars could have harbored life. The evidence of ancient riverbeds and the presence of key minerals suggests it may have been habitable long ago. But the question has always lingered. If life began there, did it remain isolated? Or was it part of a larger galactic network of exchange? Interstellar objects like 3I Atlas may be crucial in answering this. If the composition of 3I Atlas reveals organic compounds similar to those found on Mars, it could suggest that such materials are universal building blocks, distributed freely across the galaxy. Conversely, if it bears exotic chemistry unlike anything known in our solar system, it would expand our sense of the diversity of environments where life might arise. Mars becomes the perfect witness for such a study, a world on the threshold of exploration by human hands, and now a staging ground for cosmic chemistry lessons delivered by a passing wanderer. Another dimension worth considering is the role of Mars-based technology in this event. While Earth's observatories will certainly dominate much of the coverage, Mars orbiters have a special advantage. Free from Earth's thick and often turbulent atmosphere, they can observe the faint glow of 3I Atlas with unparalleled clarity in ultraviolet and infrared wavelengths. These observations might reveal subtle details about the object's temperature, surface properties, and whether it is shedding dust or gas. If 3I Atlas happens to display cometary activity with jets streaming from its surface, Mars-based instruments might even capture this behavior from a unique angle. Such a perspective would allow scientists to triangulate observations with Earth-based data, producing a stereoscopic view of an interstellar comet, a first in human history. These dual vantage points would turn the solar system into a laboratory, with Mars acting as both student and collaborator. The approach of 3i Atlas also invites us to reflect on the nature of interstellar travel itself. Science fiction has long imagined humanity reaching other star systems, but in reality, the first emissaries we encounter are not ships we launch, but natural wanderers arriving on their own. These interstellar objects demonstrate that star systems are not isolated. They leak material into the broader galaxy. This flow of matter between stars hints at an interconnectedness that transcends light years. One could imagine that the galaxy is a vast ocean, and stars are islands, with comets like 3i Atlas serving as driftwood, carrying stories from shores unseen. Mars's encounter with this visitor is, therefore, a reminder that the barriers we perceive between worlds are porous. In the grand exchange of cosmic material, no star system is an island. Philosophically, there is something deeply humbling about watching a body like 3i Atlas streak past Mars. Humanity's exploration of the Red Planet is still in its infancy. We send robots, land rovers, and dream of sending astronauts. But compared to the distances traveled by 3i Atlas, our efforts are modest. This object has crossed interstellar gulfs, endured countless eons, and arrived here almost by accident, whereas our machines struggle to cover the 54 million kilometers between Earth and Mars. Its effortless journey across such vastness contrasts sharply with our halting steps into space. Yet rather than diminish our endeavors, it magnifies them, situating them in a larger continuum. It tells us that we are participants in a galactic drama much older and grander than we ever imagined. Mars becomes not just a destination, but a stage upon which the galaxy briefly sets a prop. From a cultural standpoint, events like this resonate far beyond science. Ancient civilizations charted the heavens, drawing myths and stories from the motions of celestial bodies. Today, while we no longer attribute divine agency to planets or comets, the emotional impact of such alignments remains potent. The sight of an interstellar object near Mars will inspire artists, poets, and storytellers just as much as it inspires scientists. In an age where humanity sometimes feels constrained by terrestrial concerns, this reminder of cosmic scale can rekindle imagination. The symbolism of a distant traveler brushing past the planet most often associated with human exploration is too powerful to ignore. It is as though the universe itself is reminding us that exploration is not confined to one world or one species. It is a universal impulse, written into the very fabric of matter. Practically, the passage of 3i Atlas highlights the urgency of advancing planetary defense and interception technologies. Though 3i Atlas itself poses no threat, its sudden arrival underscores how little warning we often have for such visitors. If humanity wishes to one day send spacecraft to intercept interstellar bodies, or even to defend against potentially hazardous ones, we must refine our ability to detect and track them earlier. Mars, in this context, plays a symbolic role. The technologies we are developing to explore Mars, autonomous navigation, rapid response instrumentation, advanced propulsion, are the same kinds of technologies we might one day adapt to intercepting an interstellar traveler. Thus, Mars becomes not just a bystander, but a proving ground for the skills we will need to master the galaxy's challenges. Another implication of 3i Atlas's Mars passage lies in the field of comparative planetology. By observing how the interstellar body interacts with the Martian environment, how sunlight reflects off it from Mars's skies, how its position shifts relative to the planet's orbit, we gain insights that cannot be obtained from Earth alone. Even the way dust in the Martian atmosphere might affect its visibility offers lessons in observation under alien skies. Scientists will be able to compare data gathered from Earth and Mars to calibrate models, improving our ability to interpret distant observations in exoplanetary science. Every piece of information becomes a stepping stone toward understanding not only this object, but countless others that await detection. What also makes this moment profound is its rarity. Interstellar objects spend only a short time in our solar system, traveling at velocities that make capture impossible with current technology. Their windows of visibility are measured in weeks or months, not years. To have one pass near a planet already under intense scientific scrutiny is a stroke of extraordinary fortune. It reminds us that science is as much about seizing moments as it is about long-term planning. The cosmos does not wait for us to be ready. It delivers opportunities on its own schedule. Mars's proximity to 3I Atlas's path is one such gift, and how fully we take advantage of it will define the legacy of this encounter. Even beyond science, the symbolic weight of this passage cannot be overstated. Mars has long represented the horizon of human aspiration. When we imagine leaving Earth, Mars is the first stop. That an object from outside the solar system will briefly share that horizon deepens the sense of destiny. It suggests that as we reach toward Mars, we are simultaneously reaching toward the galaxy. The line between planetary exploration and interstellar exploration blurs. By the time humans walk on Mars, they may look back at the records of this event and see it as a foreshadowing, an omen that Mars is not the end of the journey, but the beginning of a much larger one. There is also a question of legacy. Centuries from now, historians of science may look back on this era as the dawn of interstellar studies. Just as the first telescopic observations of Jupiter's moons revolutionized astronomy in the 17th century, the first systematic studies of interstellar objects in the 21st century may be seen as a turning point. 3I/Atlas, passing Mars, will be a landmark in that story. It represents not just data collected, but a paradigm shift in how we view the cosmos. We are no longer confined to studying only what was born under our sun's light. We are becoming students of the galaxy itself. Mars, with its thin skies and red deserts, is suddenly woven into that narrative. A participant in humanity's first steps into interstellar science. The anticipation of 3I Atlas's Mars passage is therefore layered. On the surface, it is a chance for stunning science, spectra, images, trajectories. Beneath that, it is a philosophical and cultural milestone, a reminder of our place in a vast galaxy. And at its core, it is a challenge. To recognize that such opportunities are rare and fleeting, and to prepare ourselves for the many more that will come. Every interstellar object we encounter is both a mystery and a message. This one, approaching Mars, is telling us that the time has come to think of exploration not just in terms of planets, but in terms of stars. Not just in terms of years, but in terms of eons. As the moment approaches, excitement will build, observatories will schedule precious hours of telescope time, orbiters will ready their instruments, and scientists will prepare to analyze terabytes of data, but the meaning of this event will extend beyond labs and observatories. It will ripple through classrooms, where students will learn that Mars once hosted a visitor from the stars. It will ripple through art, as creators find inspiration in the convergence of two symbols of exploration. It will ripple through our collective imagination, reminding us that even as we strive to reach Mars, the universe is already reaching out to us. And so, 3I Atlas's passage near Mars will not simply be another note in the annals of astronomy. It will be a moment of alignment, scientific, cultural, and cosmic. A traveler from the stars will brush past a planet that represents our future, and in that fleeting encounter, we will glimpse both where we have come from and where we are going. The upcoming passage of 3I Atlas near Mars invites us to consider not only the immediate scientific rewards, but also the broader frameworks it touches across multiple disciplines. An interstellar body appearing in the skies of the red planet becomes a focal point for disciplines as diverse as astrophysics, geology, planetary protection, exoplanet studies, and even philosophy of science. Each perspective adds a new dimension, demonstrating just how vast the implications of this encounter are. The object is not just a fragment of rock and ice cutting across the solar system. It is a carrier of perspectives that extend into every branch of cosmic thought. Another striking angle is the field of planetary atmospheres. As 3I Atlas passes Mars, its interaction with solar radiation and the Martian environment may be measurable. If the object sheds dust or volatiles, those particles could momentarily interact with Mars's thin atmosphere, offering a chance to study how alien material behaves under Martian conditions. This would not be direct contamination, but rather a subtle interplay at the edge of detection. For planetary scientists, even the possibility of such interactions sparks excitement, as it mirrors scenarios of past epochs when Mars itself may have been bombarded with cosmic debris. Did such interactions seed Mars with organics in its ancient past? If similar events occurred millions of years ago, they may have subtly altered Mars's surface chemistry in ways we are only now beginning to uncover. Beyond chemistry and atmospheres, the dynamical properties of 3I Atlas bring fresh insights into celestial mechanics. Tracking its orbit near Mars provides a rare chance to refine models of interstellar trajectories. Each interstellar object observed allows astronomers to better understand the gravitational landscape of the solar system, how objects are bent and deflected as they pass. With Mars in the equation, the situation becomes more complex and more informative. Tiny gravitational tugs from the red planet could slightly alter 3I/Atlas's course, producing measurable deviations. These subtle shifts help scientists refine estimates of the object's mass and density, properties that are otherwise difficult to determine for something so small and distant. The ability to combine Earth-based and Mars-based tracking further sharpens this precision, giving researchers a multidimensional map of the object's journey. There is also a methodological revolution embedded within this event. Astronomy has always been a field dominated by distant observation, but interstellar objects challenge that paradigm. They are not stars to be studied from afar. They are visitors intruding upon our celestial neighborhood, close enough to engage with directly. The Mars encounter highlights this shift by suggesting that interplanetary infrastructures, rovers, orbiters, and one day human explorers can become instruments of interstellar study. The red planet, with its network of machines, is inadvertently stepping into a role as a collaborator in galactic science. This marks a turning point. Planets are no longer just the subjects of study, but also vantage points for studying the galaxy itself. Looking deeper, 3I Atlas forces scientists to confront questions about diversity among interstellar bodies. With just 3 confirmed so far, Oumuamua, Borisov, and now Atlas, the sample size is small, yet each has been unique. Oumuamua was enigmatic, lacking a typical cometary tail yet showing signs of non-gravitational acceleration. Borisov looked much like a solar system comet, reinforcing the idea that certain processes are universal. Now, as Atlas approaches Mars, anticipation builds around whether it will conform to one of these archetypes or introduce something entirely new. If it reveals unexpected features, such as unusual isotopic ratios or structural anomalies, it could expand the taxonomy of interstellar objects. Mars's close proximity offers a second set of eyes that might be essential for identifying these anomalies, reducing the ambiguity that often arises when only Earth-based instruments are used. The philosophical dimensions of this event cannot be overlooked. Humanity has long sought to situate itself in the cosmos, wrestling with questions of origin, uniqueness, and destiny. Interstellar objects complicate and enrich these questions. They remind us that the material fabric of the universe is not confined within neat stellar bubbles, but is shared, exchanged, and scattered across vast distances. The dust that falls on Mars from 3I Atlas might be composed of atoms forged in supernovae around distant stars. For humans who may one day stand on Martian soil, the knowledge that particles above their heads once belonged to another system altogether transforms the experience of exploration. It is not only about stepping onto another planet, but about encountering the wider galaxy in tangible form. On a practical level, the encounter underscores the importance of developing a rapid response infrastructure for astronomical phenomena. Interstellar objects are fast and fleeting. To extract maximum knowledge, instruments need to be repurposed quickly, observation schedules adjusted, and international collaborations activated without delay. The Mars passage of Atlas offers a test case. Scientists will attempt to synchronize Earth and Mars-based observations across different instruments and agencies. This kind of coordination represents the future of astronomy in an age of interstellar discovery. As more such objects are expected to be found in the coming decades, the Mars passage serves as a rehearsal for how humanity can mobilize its planetary and interplanetary assets in unison. A broader perspective situates this event in the unfolding story of exploration. Mars has always been a canvas upon which humanity projects its ambitions and anxieties. The Viking landers of the 1970s sought life and found enigmatic chemical results. Rovers like Spirit and Opportunity transformed barren landscapes into familiar terrain of hills and valleys. Curiosity and Perseverance now drill into rocks and cache samples for eventual return to Earth. Each of these steps is a chapter in humanity's slow embrace of Mars. Now, Atlas writes a new chapter in that story, not by what it reveals about Mars itself, but by what it shows Mars observing. It elevates the red planet from an object of study to a participant in the study of the galaxy. This is a subtle but profound shift, positioning Mars as more than a future colony. It becomes a partner in cosmic exploration. In the realm of planetary defense, there are lessons as well. Interstellar objects remind us that the solar system is not a closed box. Hazards do not always originate here. Some may come from afar. While Atlas poses no danger, its speed and trajectory highlight the challenges of predicting and mitigating such threats. A body traveling at interstellar velocities leaves little time for response. Studying Atlas near Mars provides valuable data for refining early warning systems and modeling impact scenarios. Even though the object will pass safely, its path offers insights into how interstellar trajectories might intersect with planetary orbits. The better we understand these dynamics, the better we can prepare for future encounters that may not be so benign. The encounter also resonates with questions of time and scale. Consider that Atlas may have been traveling through interstellar space for millions or even billions of years. In that time, entire civilizations may have risen and fallen on Earth. Entire continents have drifted. Oceans opened and closed. Mars itself transitioned from a wetter, potentially habitable world to the dry desert we see today. The object's endurance across such timescales places human history into perspective. Our telescopes have only been able to detect such bodies for a few decades, yet the cosmos has been sending them all along. The Mars passage is not the start of their journeys. It is simply the moment when our awareness intersects with their paths. From another vantage point, this event illustrates the democratization of astronomy. Data from such encounters often become available not just to elite institutions, but to researchers, students, and even amateur astronomers around the globe. In the case of Atlas, Mars's proximity may inspire simulations and analyses by a wide community, extending the impact beyond professional circles. Citizen science could play a role in refining observations, modeling trajectories, and even suggesting new methods for detection. The symbolic connection between an interstellar traveler and Mars, the most humanly relatable of planets, ensures that public interest will remain high, driving broader participation in the scientific process. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas passing Mars? Will NASA discover something unexpected? We want to hear from you. Thank you for watching and see you next time.